Beautiful mug to have on shot. All right. So today, nope. Yeah, there's no class today. So today is going to be an example lecture. I have a lot of live demos planned, and we're all going to hope that everything goes well. I think it'll go fairly well, but I want to show some examples of running a database, connecting to the database, and just getting all that set up, and we'll go up to Docker Compose. So this will be a lot of the information that you need to be able to complete your project phase 2. Getting that database hooked up is a big step of phase 2. It is storing this data and getting it hooked up with Docker Compose. And actually, while I'm here, I knew I was going to forget this, and I'm kind of happy that I did. I'm not upset that I did. Is updating the course website. I just have 2 links. There's no slides for today, like I said, but there are 2 links to help you get through this process. One's the Docker Compose link for that software itself, and the other is a kind of a workaround to an issue that we're going to talk about later when we get to that part of the lecture. But I forgot to pull the repo. I updated my repo, but I didn't pull it to the live server. So we get one of these examples. So you see, I'm going to go into my 312 directory, get pull. Oh my goodness. I am not going to... I know that didn't pull, but let me go back here. So if we go to the course website, no content there. It's not going to be as smooth as I want it to be. Get pull. That's going to pull my new content. It just has those 2 links that I added. And then I'm going to... Oh, I've made so many commands since then. I'm just going to do it this way and cheat a little bit. And then I'm going to restart the app. I'm using software called PM2 to run my app in the background. And we're just going to restart that app so we get the new content. And if we refresh, we'll see those 2 links that I just mentioned, but no slides. So with that, so what I have here, it's just, let me take one more sip of coffee and then dive into this mess. I shouldn't call it a mess, but live coding is always dangerous. So let's clear this out and look at what we're going to talk about today. So here's an app that I have that I built for this example, and guess what? Hey, it's another chat app. I know, but chat is the kind of like the core, like minimal app that can show off all the technologies that we need. So I like doing chat apps just because we don't get bogged down with all the details of a complex app, but we can see all the technologies that are in play. So let's look at the app itself. And for this, we're going to be looking at Node quite a bit today. Node and Mongo are going to be the technologies we'll use for a lot of the examples today. Is my mouse? Okay, it's on that screen. So let's take a look at the app. Let me give an overview of what the app itself looks like, and then I'll highlight the database portions of this. We very, very briefly saw how to really use a MongoDB database out in the wild right at the end of yesterday's lecture. I just very quickly flashed it on the screen. So let's dive into that a little bit more today. And then towards the end, I'll have, similar to what I did last lecture, but reversed, I'll do a really quick flash of MySQL at the end of today's lecture. Where last lecture I focused on MySQL quite a bit when I was talking about the background information. Now when we're getting into the examples, I'll highlight MongoDB more, just to kind of spread it out a little bit, because I don't want to focus on either one of these too much, because that's given certain teams an advantage. So here I'm using Express, Socket.io, and Node to build my app. These are all technologies that you can use for your projects. Again, this is a project week. There's no homework for this week. It's project phase 2 week. So libraries on the table for the project as usual. So I have these libraries. Express is going to be able to do my routing. When somebody requests the route path, I'm going to just send them my index.html. Nothing fancy. But this, of course, would take us quite a bit of code in the homework assignments, and it did take us quite a bit of code. But with a framework, with a web framework like Node, HTTP, and Express, it's no big deal. Just at this, when somebody gets this path, send them this file. It's going to handle the content length, the MIME types, all that good stuff for us. Let me skip that for now. I have a chat history path, which is going to serve all of the history of the chat, as the name implies. And it's going to access my database to do this. I'll highlight the database stuff in a minute. I just want to give a quick overview. If a request doesn't hit any of my pathing, so it's not / it's not chat history, and it's not any file in my public folder, then it's going to get 404 and send that 404 response. I'm also setting up my WebSocket connection. I'm using Socket.io. Socket.io will respond to the connection event. So when a connection is established, this is after that handshake all occurs. The key was received. The accept was sent back. After all that happens, I'm going to get a connection event, and the library is going to tell me, hey, everything's set up. What do you want to do with this socket connection that we just established for you? And I'm going to get a reference to that socket. And I want to say that socket, whenever it receives a message of type message, this is part of the Socket.io library. Each payload in a web frame that I receive is going to have a message type, just the way it's encoded for Socket.io, but by this library itself. So when I receive a WebSocket message, a Socket.io message of type message, I'm going to parse that as a user sending their message. I'm going to expect it to be in a very specific JSON format, and I'm writing that same format on my client side, in my client side JavaScript. So I'm going to expect that format, which is a JSON object with a username and message. I'm going to pull that information out of there. Very, very importantly, I'm going to escape the HTML, as we talked about. And oh, I didn't mean to show this, but I guess I kind of have to talk about this. And for those of you who like to spam the BMovie script, if the length of your message is too long, I'm going to truncate that thing. Because it seems like every time I put an app out there on the internet for a class to play with, I always get the BMovie script. It was funny the first few times, but it's always the same thing. But anyway, then I'm going to insert that into my database and broadcast that message to all sockets. Again, the library helped us out here. This is where you're all working with the concurrency. Some of you are working with multi-threading, storing references to all those socket connections and everything. Here, the library is going to store a data structure with all those sockets. And I'm going to emit a message to every single one of them. The library uses this emit verbiage to be able to say, this is how we're sending a message. So we're sending and receiving messages. When a user connects, they're going to make an AJAX call to chat history, get all of the history. When any user sends any message, that message is going to be saved in the database and broadcast to all users. So we can get the chat history when we first log on, and then only get the new messages as they come in over the WebSocket. So we're combining AJAX and WebSockets to get the functionality that we want. So let's talk about the database. That's what we're here to talk about today. And for this, I'm actually going to use two libraries for this. MongoDB is the connector, which is going to connect Node to an existing MongoDB server. So remember, we're going to have a MongoDB server running somewhere, and we're going to have to create a connection, connect to that server to be able to send it MongoDB queries. We're going to send it information. We're going to pull information out of it. I'm also using a library called Monk. This just helps with the syntax a little bit. It adds a little bit of friendlier syntax than the MongoDB library itself. Specifically, MongoDB would have a good number of callbacks. I would have to either work with promises, which isn't too bad. It's not the worst thing. or have a callback function and have my entire app and a callback. I don't really want to do either of those, so I'm going to pull in this library that just gives me friendlier syntax and wraps all the callbacks and stuff inside the library. So I'm pulling in 2 libraries. I would have to write 2 reports if I was using this for my project to explain what both of those are doing and where in the code is it doing the things that I want it to do. So that would be 2 reports for me, plus 1 for Express, 1 for Socket.io, 1 for escape.html, and 1 for HTTP here. So I would have a lot of reports to write with those imports. With my once I have my database connection code, my client code for the databases, I'm going to ask Monk to make this connection. This is where Monk gives me some nice syntax. I just give it the URL, give it the base amount of information that I need. I need to give my connection library the URL, and it should be able to handle the connection from there. We're using MongoDB with no password, which is something we'll talk about in a second here. But we're using MongoDB with no password, so I don't have to provide a username and password here. So I'm going to make that connection. I have a reference to my database. I have a reference specifically to the database named chat. So if this doesn't exist, the first time I connect to it, it's going to create it. And then I'm going to get a collection named history. So MongoDB has a few layers. It's the MongoDB server. That server can contain multiple databases, and each database can contain multiple collections. So I have to go from server, connect to the server, connect to a specific database, and then get a specific collection out of that database. And then the collection is where I'm going to store my JSON style objects. That's where my information is going to be stored. So after all that connection, I really want a reference to the collection where I'm going to store my information, which I'm just storing this variable chat collection. So that collection is what I'm going to work with from here on out. Now that everything's connected, I have the right database and everything. That's really what I was after, is that connection. Set up the server, set up the WebSockets, listen on port 8000, some things we already talked about, and then when I have my collection, I can insert directly into that connect collection any JSON object style of information that I want to store. So here I'm giving it a JavaScript object, and the library is going to convert that into a MongoDB object to be able to store that in this collection. So I'm storing this object in the collection. That's going to be there. From now on, it's going to persist in that database, broadcast it to all users, which we talked about. And then when I want to pull information out of this database, so when somebody first connects, that's actually the only time I'm pulling information out of the database, is when a new user connects to the app. I'm going to go to my chat collection, call my find method, this with an empty query. So this is the same, if you're used to SQL, this is the same as select star from table. I'm effectively selecting star from my chat collection. So chat collection.find with empty query, this is going to return everything in that database. And then I'm going to filter out that ID like we saw last time, though I believe this wasn't necessarily working when I tested it. I was still getting the IDs, but it doesn't hurt anything. I've had issues with that before, depending on different versions of all these libraries. It's a frustrating world in development sometimes, but this works on some versions, doesn't work on others. This find is going to happen concurrently. For those of you working with Node, you've probably already been feeling this. You've probably already brushed up against this. But if you're confused or wondering what's happening with that, Node and JavaScript in general is made to be concurrent. So with all your classmates working with Python or Java, and they're talking about concurrency and trying to get this concurrency working for the WebSockets, with Node is just naturally concurrent. So that might be something that you haven't really worried about. But where the challenge comes with Node is actually writing code that is not concurrent. If you don't want things happening simultaneously, then things get a little trickier. And for that, we use either callbacks or promises to be able to run code that depends on other code. So when I call any code in Node that is going to perform any type of I/O, usually file I/O or network I/O, it's going to run that concurrently. So when I do chat collection.find, this whole thing is the call to find. All this code is inside that find call. When find is called, we move on to the next line of code immediately. Find is called, that request is sent to the database, and then the program moves on. And that happens concurrently. So when this request, this information is being sent, well, this query to get this data out of the database is sent, the rest of my code keeps running, which is a feature that we really need in the WebSocket code. We want to accept the connection and have that connection doing its thing in the background while our code keeps running. Node just does this naturally. It's how JavaScript is built. It's built from the ground up with concurrency in mind, which is one of the really nice features about JavaScript. But if you don't know that it's doing that, it can cause some headaches. So when this database gets back with the answer to this query, it's going to call what's called a callback. So the third argument that we give this method call is a callback function. This function is going to be called when the database has our data ready. So that file I/O is an expensive operation. We don't want to halt everything else we're doing to wait for that operation. So when we get our data back, this function is going to be called with the appropriate results from that query. Either this error message, the details of any error. If there are no errors, this will be undefined, and the data that we requested. So if that error is not undefined, we're going to handle that error somehow. I'm just printing it to the screen and sending error to the user. Otherwise, it shouldn't be printing the data to the screen name. Actually, we can, let me leave it just so we can see what's going on. Otherwise, I'm going to send all that data back to the user. This data is going to be in an array of the objects that are the results of the query. So I'm going to send the user just that format directly. This is an array of all the objects or all the documents, using the MongoDB terminology, that we put into this database. So every object with the username and message is going to be in an array. I'm going to send that to the user. With Express, send is going to take that JavaScript array. It's going to stringify it. It's going to find the content length. It's going to put together my HTTP response. It's going to do all that good stuff for me, which would all go in my report to be able to send this information. But I just do response.send and give it the information in whatever format I choose. And then the library, as long as it handles that format, it's going to work. It's going to put that in the body of an HTTP response for me. All right. So, let's, one thing I gotta learn, I'm a little too old school, I guess, but I never learned how to type. They taught me cursive in school instead of typing. I have my opinions, but computers just weren't that big of a deal back then. Today they should be teaching you all typing, but I never really had a lot of formal typing, so I'm going to try to not look down at my keyboard too much. Don't make fun of me too much. So npm install, is that it? It's just npm install? Yeah. So I don't have my requirements installed, so I'm going to download all my requirements. That happened kind of scarily fast. And then I have this app running on port 8000. And if I go to my other screen here, I can do curl http localhost. I'm trying to just guess now. Localhost 8000. And I can see my app right there. It reads from package.json. Yeah. So I have, let me explain that for anyone who hasn't worked with this before. But we can see that I have my app here. We'll actually go to the app in the browser in a bit. But for now, let me... what am I doing wrong here? I still don't know what I was doing wrong, but it worked that time. I have this package.json, which is storing all my dependencies. I showed this a few times in class, but it's a little more relevant to what we're talking about this time. Yeah, cursive does not come in handy at all. The only defense that they say is, how are kids going to know how to sign their name if we don't teach them cursive? Like, I think they'll figure it out. They only have to figure out the letters in their name and how they connect to each other. They don't have to know the whole... an R is different if it's followed by this character. You know, they don't have to do all that. It's completely outdated. Typing is a very useful skill, on the other hand. Anyway, this has all my dependencies listed. That all the libraries that I need to import relevant to this conversation, MongoDB and Monk, all my Express stuff. I'm not using some of this stuff, but I just didn't update my my package.json when I removed those packages. And my socket.io is important. Requests I'm not using. A lot of that I'm not using. But the Monk, the Mongo, the Express, the socket.io, these are all things that I'm using. My escape HTML, very important. All these I'm using. All right, so that's fine. But I can't really access my app right now. Actually, I take that back. We might be able to. Nope, I take back my take back. Yeah, people print their name instead of signing. And honestly, these days, how often do you even have to sign your name? If we're signing, a lot of the signing is literally typing it into a web app. You don't really sign too much these days, except I guess like making credit card purchases. But if you just scribble literally anything, they're going to accept it. You don't actually have to sign your name in a legible way. You just write some scribbles. I mean, I went through the cursive program. In my signature, I still just scribble random stuff. I'm not making perfect letters. I don't think many people do with their signature. If your signature is perfect cursive, doesn't that defeat the purpose of having it as a security measure? If anybody who can write perfect cursive can simulate your signature, it's kind of defeating the purpose anyway. So let's look at some other good bits here. Because I can't access my app. We could actually at this point, but that would defeat the next thing that I want to talk about. So what we're going to do is pull in our Docker. This is old news. You've all done this for phase 1 of the project, but I'm going to use a Docker file to start my app. I don't really know what else to say here. There are 2 lines here, and then this wait. These are important. This is the second link that I talked about in the course website. That's that second link. These are very important things we're going to talk about in a second. But let's talk about the other really important thing. Now that we're in full swing here, let's talk about Docker Compose. So I'm going to have my same Docker file, which is going to run on port 8000, except we're going to take this to the next step and start using Docker Compose instead of just Docker. So we can run this using Docker as usual, but we have this extra issue that we have to run a database as well. And we can run... Actually, you know what? I do want to do that, don't I? Docker build. Just thinking about the T and type the T. Docker build -T. Jeez, chat, I guess, and then dot. This shouldn't take too long. Then we'll run this thing, and we actually can get this live, just so I can make a better point about the Docker stuff. So Docker run dash publish chat. Oh, damn it. Port already allocated chat. I just kill star. How do I kill all of these really quickly? The other two are, oh, I don't even want to kill them all. And then let's try to run it there. Okay, so my container's running on port 8080. I mapped that to, or port 8000. I mapped that to port 8080. At this point, I should, and this is where I'm going to hold my breath. We do see our app. Let's see. Whew. Okay, that's always a stressful moment to see if things are actually going to work the way I want them to. So tictactoe.info. So I have this domain name mapping to my port 8080 on this server. Yes, there it is. So I have port 8080 mapped to, or tictactoe.info, the DNS records pointing to port 8080. Well, we'll get into that in another week. But anyway, that domain name is going to port 8080 here. So when I run my app, I have to do the script. It would be hilarious, funny and original to post the BMovie. I actually haven't, to be honest. I haven't tested my character limit. I don't see why it wouldn't work, but it's possible that that's broken. So you might as well try it. So we can play around with this during lecture, get some more interactivity here. So I am gonna have to shut the server down though. So what we proved here is that we do have a database, right? No, we didn't prove that yet. But once we refresh, oh no. I forgot. I held my breath on the wrong part. All right, yeah, I'll be starting it up and shutting it down over and over. Come on, give it to me. All right, so we didn't get that the way I wanted it to. Chat. Okay, so we get that back. I'm not gonna debug it. I'm just gonna go on to the next step. But so we didn't get to prove that we have a database running on that one. That one's kind of sad. But the next step of that is to use our Docker Compose. So what I was trying to do there was to use my local instance of MongoDB that's running. So I have MongoDB running on the server, and that's when we did the curl. Oh my goodness, 27017. When we did the curl, we can get this, hey, what are you doing message. It looks like you don't know what you're doing. We can get this message to verify that MongoDB is up and running. But that's not what we want to do for the project. We don't want to download, install, run MongoDB. What we're going to do is do this through Docker. So we're going to take a MongoDB image, which we could have a Docker file. Let's see if I can pull this up quick. We can have a Docker file. I didn't copy that over, did I? Damn it. But we can have a Docker file that just says from. Oh my god. We could have a Docker. All right, I'm going to get to the end of the sentence, I promise. We could have a Docker file that says from Mongo 4.2.5 or whatever version you want to use, and then expose 27017. That could be our entire Docker file, and we could run an instance of MongoDB in Docker by taking the MongoDB image and then in running that image. So I'm going to skip that step just in the interest of time, but I could find it, pull it up, or just write one. From Mongo 4.2.5, expose 27017, and that gets us our MongoDB running in a Docker container. That way you don't have to worry about the installation process. You don't have to worry about differences between operating systems. You throw it in a Docker file and leverage Docker to be able to get that up and running. So yes, it is supposed to save previous messages, but it didn't exactly work. But we're going to get to the next step and get to one that did work. I'm fine if the intermediate steps don't work exactly as planned, as long as the final one does. If the final one doesn't, I'll cry. This version at the top, so the Docker Compose file has to be a YAML formatted style, which is a format kind of competing with JSON. JSON really took over, but some instances, some cases, people are still using YAML. Specifically with configuration files like this, YAML seems to be the popular option still. So one more format that we all have to learn and know. But the version of Docker Compose has to be specified. So we're saying we want to use version 3.3 syntax. You can use whatever version you want. I happen to choose 3.3. I don't remember why. Then list all the containers that we want to run when this Docker Compose file is executed. So when we run this app, so we have multiple containers is the problem. We could have two Docker files for the containers and then run each Docker file. But Docker Compose is going to give us a way to build one app that uses multiple containers. And that's what we're getting here. So I'm going to list all my containers that I need to run. I need an instance of Mongo running. And I'm going to expose its port 27017 so I can access this database running inside a container. And then I'm going to run my app as well, and give it the parameters that we need. The build, this is the context where it's going to be built. This is whatever directory you should be in when you do Docker build an image. When you build an image, you have to give it that last parameter of what directory we're in, and we usually just give it dot for the current directory. We have to do the same thing here. We have to specify where we're building from. Then we can set any environment variables that we'd like. Here I'm setting one variable, this wait host Mongo 27017, and this is related to that second link again that I mentioned. Let's get this app up and running, and then I'll go back and talk about all of what that is doing. And then the ports, anything that we have to specify when we either build or run a container, all that information has to be here. So the ports that I want to expose, I want to map local 8080 to the containers 8000. So with this Docker compose file, when I run this using, Docker compose build, it's going to build both of those images that I need, which again will be pretty quick because I already built these on the this server, so a lot of these steps can be skipped. So we're going to build, and then is it up? Oh man, I'm blanking. Yeah, and then Docker compose up is going to run my containers. And if this went well, actually I just thought of something. This really shouldn't go well, but it did. Of course it did. Of course it did. Anyway, I shouldn't be mad that it worked, but we are connected to a database. So we can verify that. When we ran this thing, we have my console.logs here, which I could have removed that I mentioned earlier. But we can see everything running when we build and run this container. So we're building the MongoDB container and the app container, but we have a problem here that when we build these, I knew that was the wrong one. When we build these containers, and run them, so we're running these when we do Docker compose up, we're running these containers right away, but they're being ran concurrently. So when I get to this line in my code, when my app is firing up and we're running this container, when I get to this line right here, I'm connecting to a MongoDB database, but in all likelihood, that database is not up and running yet because my container isn't running yet. So, I did change this. You know what? Now I remember, I did go in and change this. If you saw me change this from localhost to Mongo, that's the change that I did to make this work. I forgot that I did that. I thought that I had forgotten to do that. That's why I was surprised. Like, that shouldn't have worked. If this is localhost, this doesn't work. It would connect to the local database, which we already showed. I had some issue there. But if I put Mongo here, that's going to refer to the Mongo container instead of the localhost port. So I'm going to go to that containers 27017 and be able to connect to that. The problem here is localhost refers to the container's localhost. Like, we basically have three different localhosts. We have the database container's localhost, the app container's localhost, and the actual server's localhost, the actual box's localhost. So if I put localhost here, or if I put 0000 or whatever, what does that refer to? How do I tell this thing to go into that Mongo container? And the answer for Docker is to specify the container name that we specified in that Docker compose file. That's going to go to that container. Since that container's 27017 is exposed, I'm able to connect to that database and connect to the database that's running inside that Docker container and not the database that's running locally on my machine. So, but we have to have that server up and running before we can connect to it. And that's where those lines come into play. When we build our app's Docker container or Docker image, we're downloading this code from that link that I referenced. We're downloading that code as that has this wait function in it. Change the mod to make sure we can run it, and then running that before we start our app. So we're going to call this wait command that wait command is going to read our environment variables, and it's going to look for this wait hosts environment variable, which is going to specify, which is where we're going to specify what you should wait for. So this is going to say, don't do anything until the Mongo container has something for you at 27017. Something has to be alive at this host and this port before you build. So we're adding a dependency. We're saying don't do anything until this is done. So this is kind of a workaround. Docker Compose surprisingly doesn't really have anything built in to be able to do this. So we have to have some sort of workaround. I searched around for a while. This seemed like the easiest one to use, but there are a lot of different workarounds out there. So Docker Compose, you can wait for a container to build before you start your container. You can have dependencies like that, but the problem is this container is done building and it's up and running before the server is actually started. There's a delay when you hit, hey, server, start running. Once the server starts, Docker is going to get that signal and say, whoa, okay, you're ready. But that server is actually booting up still, and it causes a lot of issues. So here we can see in our logs, we're checking, is it available, not available. Docker or Mongo is getting up and running. Check again, is it available? No, still not available. Docker, Mongo getting up and running, going through all of its boot up process. And then, okay, now it's available. Now we can start our app. Now we're listening on port 8000. Now when we get to that connect to MongoDB, it's not going to crash. We're not going to break at that point. We're going to actually have a running live database to be able to connect to. And then the database, you can see it's getting that connection from our app, and it has some logs for us, and then my console.logs later on down here. And of course, I want to show the logs here, so I didn't do that -- detach. But the detach, that's what we would do to run this in the background, just like we did before. X, yeah. It's still up and running, right? Okay. And yeah, BMovie got truncated there. Oh, damn it. You're right. That you should get some extra credit for that one. Damn it. Yeah, if you go into the oops. Man, I can't type. Why am I so bad at this? Name equals. Why did that not work earlier? Do I have? I don't even see what's wrong there. But yeah, you can totally get the BMovie in there. That's a good catch. So I'm not even as protected as I want to be against that. Can't you use the Docker depends on? So Docker depends on, that's what I'm talking about. That'll wait for the container to be running. But once the container is running, MongoDB is still going through its whole startup script before it's actually ready to accept a connection. So using depends on right here, once this container starts running, my app is going to say, oh, hey, that other container's ready. I'm going to start up right now. And then right here, maybe you're going to get your app trying to connect. But since it's still going through its startup script, where Docker has no way of knowing like what the startup script is, when it's ready, when it's done, there's just nothing built into Docker or Docker Compose to be able to know that. So you're gonna get that connection somewhere in here, trying to connect. Server's not ready, app crashes, everything's bad news after that. So we do need something a little more than depends on. There are other workarounds too, but it's not as simple as depends on, unfortunately. All right, so I want to show at least one more thing here. We only got a few minutes, but let's go to my Python. So let's see Python and MySQL. I told you I want to flash MySQL right at the end of lecture today. So let's talk a little bit about MySQL, and I want to highlight this environment variable username and password stuff that I mentioned last time. So here we're going to do the same thing in our Docker file. I'm going to pull from Python and do the weight and all that good stuff. But I'm going to change one big thing here. I'm going to set an environment variable with my password, which is something that I would change as soon as I uploaded to production, whenever I pulled from production, rather. I'm going to change this password. But I'm going to set an environment variable with my password, and then in my Python code, I'm going to read that environment variable to get my password. So I'm not hard coding my password in my code, and I'm not checking this password into any repositories. But I do have a default password. And this is where one of the security risks that I talked about last time. You're going to have some default password with most of the software that you use. That's something to this effect, having some change me or something as the password, or admin 123456, something like that, that you're supposed to change as soon as you take some software and put it on your production environment, so that nobody knows your password. You got to change those right away, or else the devs who wrote the software you're using, they had to put something as a default option. They're going to know your password, and so are all the attackers. So we would change this as soon as we deploy, and then read whatever we change that to in our environment. This is something you could log on to the server and change your environment variables and set your environment variables. But since we're going through Docker, we got to set those variables through Docker using this env variable. In our Docker Compose, when we pull MySQL, when we get a MySQL image, we're going to set some environment variables in that image as well, specifically the password that we're going to use. And we'd make sure this password exactly matches the Docker file password. We would need the same exact passwords there, so we're able to log on. And I'm just using the root user here. You could create a user account as well with separate passwords and have a more sophisticated setup if you want. And I'm going to set a default database name here, so I don't have to specify my database name. Expose MySQL's port, and then do the same thing that we did with Docker. Wait for MySQL to boot up before running the app. Then the app, I'll go to this one. I have this MySQL container or connector that's a library for Python that's going to, of course, connect to a MySQL server. This is my client code. I'm going to import that connector, make the connection, tell it where and how to connect, with the host being that MySQL image that we saw earlier. So we can connect to that container. I'm assuming the default port, so it's going to assume 3306. I can get a cursor, which is a way MySQL uses to work with the databases. And then I can start creating tables, adding information to tables, and doing all of the SQL stuff that we can do with that. So a little bit different setup, but a lot of the same ideas. Writing a Docker file for our app, waiting for our database to be ready, running the database, and then running the app while waiting for that database. And then setting any environment variables that we need throughout the way.